Hi guys, so in this video, our topic will be area by integration. So this application is one of the most awesome application of integral calculus. So all those formulas in plane geometry, solid geometry, those are all derived using integral calculus. So we have this curve that touches your y and x axis. So we have an area here bounded by those axes. So we are required to find this area. The first step is to get a rectangular strip. So it's a strip that actually touches all those boundaries. So this is a rectangular strip. So the whole area is the area A, but if you get a differential strip, it will be represented as differential of area. So it's a rectangular strip. So the length of that rectangular strip is actually your height. So that is y sub 2 minus y sub 1. But y sub 2 can be represented as y upper, and y sub 1 at the bottom, you can represent that as y lower. So it's just like a distance. So distance formula lang yan, guys. And this width here can be represented as dx since it is projected or it lies on the x-axis. So this height here is y upper minus y lower. That is y sub 2 minus y sub 1. And this width is differential of x. So the area is, of course, it's a rectangle. It is length times width. So this is a vertical rectangular strip. So y sub u minus y sub l differential x. So that is our differential of area. Now, integrating both sides, we can extract that area. So integral of differential area is equal to the integral of y upper minus y lower times differential of x. So since we have here differential of x, our limit will be x sub 1 to x sub 2. So the boundaries in x-axis. So this is x sub 1, this is x sub 2. You have here from x sub 1 to x sub 2. So our area is equal to the integral. So this is the definite integral of y upper minus y lower differential of x from x sub 1 to x sub 2. So this will be our area if you're dealing with vertical rectangular strip. So another scenario is we get a horizontal strip. Here we have this curve f of x bounded in the first quadrant. Then the area of that rectangular strip, we have here the length that is, since it is projected on the x-axis, it will be x, say right, minus x left. So x sub 2 minus x sub 1. It's a distance formula. Then you have the width here. Since it's projected in the y-axis, it's differential of y. So differential of a is length times width. So length is xr minus xl. Width is differential of y. So integrating both sides, we can extract the area. So area is equal to, we have here the integral of x sub r minus x sub l differential of y. So we have dy here. So our boundary will be from y sub 1 to y sub 2. It can be y upper minus y lower. So area is the integral of x sub r minus x sub l differential of y. So it's the definite integral. So we have here y sub 1 to y sub 2. So in our first problem, we have here the parabola x squared is equal to 4y. We have here y is equal to 5. And we are required to find the area bounded these two curves. So first step, guys, is to plot the curve. You have here the form of a parabola. You have here x minus h squared is equal to 4ay minus k. So by inspection, guys, we can say that we don't have h and k. Therefore, the vertex is 0. So you have a positive y. So if your squared is x, therefore the vertex is facing your x-axis. So it's either upward or downward. But y here is positive, therefore it is upward. So the vertex is at 0, 0. So this is x squared is equal to 4y. Then we plot the other curve. Y is equal to 5. So it's a horizontal line. So y is equal to 5. So the area bounded is this shaded figure. So you can decide whether to get vertical rectangular strip or horizontal. So let's say vertical na lang guys, vertical. So make sure that your strip will actually touch both curves. So if it touches the same curve, of course your answer will be wrong. It should have a boundary. So here, rectangular strip touches both curves. So this is a good to go solution. You have here the length that is y upper minus y lower. So width is differential of x. Then this differential of area is length times width. You have this length y upper minus y lower, so we have derived this differential of x. So integrating both sides, you have here differential of area. The integral is equal to the integral of y upper minus y lower differential of x from x1 to x2. So area is the integral of y upper minus y lower differential of x from x sub 1 to x sub 2. Now we need to determine all those elements. So what is x sub 1? So x sub 1 is actually the intersection there. So that is x sub 1, this is x sub 2. So those are the boundaries. So we need to determine that x sub 1. So x sub 1 at y is equal to 5. So just input y is equal to 5 in your parabola. You have here y is equal to 5. So substitute in the parabola. So x squared is equal to 4 times 5. Therefore, we have x as the square root of 20 or 2 square root of 5. So we have here the square root. So it means that it is plus or minus. That is plus or minus 2 the square root of 5. So this x sub 1, since it is located there in the left side, it is negative 2 the square root of 5. So x sub 2 is located on the right side. Therefore, it is 2 square root of 5. That is positive. So x sub 2 is 2 the square root of 5. So what is y upper there? So y upper touches the curve y is equal to 5. So therefore y upper is 5. So y lower touches the parabola. Therefore we need to determine what is y there. So y is equal to, we just divide by 4, so that is x squared over 4. So we have determined all those elements. So the next step is to just substitute all those elements in the formula. You have area is equal to the definite integral of y upper is 5 minus y lower, that is x squared all over 4 differential of x from negative 2 the square root of 5 and positive 2 the square root of 5. You can use your calculator here, but let's try solving this manually. You have here the integral, the definite integral of, you have here 5, just distribute this. So 5 dx minus integral of, you have here x squared. So put 1/4 outside, so the constant must be outside. This is x squared differential of x from negative 2 square root of 5 to 2 the square root of 5 is x. So limit is from negative 2 square root of 5 to 2 square root of 5 minus 1/4. So we need to add to the exponent. So this formula is the power formula. So that is x cubed all over 3 from negative 2 the square root of 5 to positive 2 the square root of 5. So we just substitute all these values. So you subtract the lower limit to the upper limit. So we are required to find this area here. So area is equal to 5. So you have here x, so that is 2 square root of 5 minus negative 2 the square root of 5. So you just substitute all those limits and subtract. Here minus, So here 1 over 12. So that is 1/3 times 1/4. So 1 over 12. So we have here x cubed. So that is 2 to the square root of 5 cubed. Don't forget your parentheses. So the groupings are important. It's a common mistake of some students. I just solve the value. So we have here 29.81. So unitless, therefore we can say that this is square units. So in the board exam, you can actually input this directly into your calculator here. So that is integral below the alpha button. So alpha x squared all over 4. So just press equals there. It will give you your answer automatically. So it's the same. 29.81 square units. Now guys, we have an alternate solution for this. So for a segment of a parabola, we actually have a formula. So if this length is A, this height is B. So the height from the vertex to the bisecting line segment there. So A is equal to 2/3 AB. So this formula guys is derived using integral calculus also. So this is already formula for a segment of a parabola. You have here 2 square root of 5. So this is negative 2 square root of 5. So the length A must be x sub 2 minus x sub 1. So you have here A is equal to 2 square root of 5 minus negative 2 the square root of 5. So this will be 4 square root of 5. So the grouping is important. It's a common mistake guys. So the height is, so if this line is y is equal to 5, so from 0 to 5. So therefore the distance is, you have 5. So the height is 5. So B is 5 units. And you just directly input it to the formula. So if you're given this type of problem guys, you can either use integral, you can either use the formula. So formula is advisable if you have remembered it. So if you forgot the formula, back to basic, you need to use integral calculus. So area here will be calculator. So that is 2/3 times 4 square root of 5 times 5. So it must be equal. So 29.81 square units. So that is our final answer. So in this next problem, we have y squared is equal to 5x. And we have these lines. X is equal to 1 and x is equal to 3. So you're required to find the area bounded in the first quadrant. So first step guys, graph natin yung curves. So this is y squared. Therefore, your vertex must face the y-axis. So it's either to the left or to the right. So x is positive. Therefore, this is facing right. So vertex is 0, 0. Facing to the right of x. So this is y squared is equal to 5x. So this will be x is equal to 1. You have here x is equal to 3. So those are vertical lines. So the area bounded is just in the first quadrant. So the total area bounded is actually in the first quadrant and in the fourth quadrant. But in this problem guys, we are just required to find the area in the first quadrant. So you must look into that. So we have decided to get a vertical rectangular strip. So same process guys. So area is length times width. So your length will be y minus y lower. So we have here the width differential of x. So area is the integral of length times width, that is y upper minus y lower differential of x. From differential of x, therefore your limit must be in x-axis. So that is x sub 1. So here it is evident that x sub 1 is 1 and x sub 2 is 3. So in the board exam guys, after you have derived the elements, you just need to input it into your calculator. But in your undergrad, of course, you need the solution, the complete solution. So your y upper here actually touches the parabola. Therefore, your y upper is, you extract y, that is the square root of 5x. So, or y is equal to the square root of 5 times x raised to 1 half. And y lower actually touches y is equal to 0 there. So it's evident in the curve. So the bottom of your rectangular strip touches this point. So the point there is actually y is equal to 0. So that horizontal line is y is equal to 0. So your y lower is 0. So all the elements are there. Therefore, you just need to substitute. So you have here area is equal to the integral of, this is the definite integral, you have the limits from 1 to 3 of, you have here the square root of 5 x raised to 1 half minus 0. So the 0 is y lower, differential of x. So we simplify this, so constant, so we bring out, you have here the square root of 5 integral of x raised to 1 half differential of x from 1 to 3. So this is power formula again, guys. So square root of 5, here we have x raised to 1 half plus 1 all over 1 half plus 1 from 1 to 3. So we just simplify this. You have here 1 half plus 1, that is 3 halves. Square root of 5. So x raised to 3 halves all over 3 halves from 1 to 3. Further simplifying, we have 2 the square root of 5 all over 3. X raised to 3 halves. And last step is to input those limits. So area is equal to, so you have 2 the square root of 5 all over 3. So substitute your upper, subtract your lower to the upper. You have here 3 raised to 3 halves minus lower limit, that is 1 raised to 3 halves. Then we simplify this. So that is equal to 6.255. That is square units. So in this next problem, guys, we have two parabolas here. Y is equal to, you have 6x minus x squared. And you have here y is equal to x squared minus 2x. So first step is to graph the curve. So we need to find the vertex, but it's evident here that it actually touches the origin. So if x is 0, y is 0. So we need to complete this square. So x squared minus 6x. It's either upward or downward. So we complete this square. So x squared minus 6x. So we add here 6 over 2 squared or 3 squared. So that is 9. So if you recall our analytic geometry, so that is plus 9. Then you also add 9 to the other side to balance it. We have here x minus 3 quantity squared is equal to negative y minus 9. So we factor this out, negative 1. So h is 3 and k is 9. So that is our vertex there. So y is negative. Therefore, the graph is projected downward. So this is 6x minus x squared. So y is equal to 6x minus x squared. Then we graph the other parabola. So the other parabola also touches the origin. So if x is 0, y is also 0. So x squared minus 2x is equal to y. So we complete this square. So we just add 2 over 2 squared or 1. So x squared minus 2x, we have here plus 1. We add 1 to both sides. So this is the quantity x minus 1 squared is equal to, you have y minus negative 1. So that is the form. Therefore, you can say here that your h is 1 and your k is negative 1. So the vertex is at 1, negative 1. Just plot those vertex. Y is positive, therefore it's projected upward. And this is our required area here. The area that is bounded by those two parabolas. So the rectangular strip can be horizontal or vertical, but the easiest way to solve this is to get a vertical rectangular strip. So it touches both curves. So this is y upper minus y lower. Your width will be differential of x. So same concept. Your differential of area is length times width. So a is equal to the integral of, this is the definite integral, y upper minus y lower, differential of x from x sub 1 to x sub 2. So x sub 1 is actually the intersection here. So that is 0. So what about x sub 2? So what is the other intersection or the boundaries? So we need to get that. So you need to equate those two equations in order to get the intersection. So x sub 1 equals 0, it's very evident. But what is the other value for x? What is the other intersection there? So you need to equate those two equations in order to get the common point. So it's a common point, it's an intersection. So if y is equal to 6x minus x squared, therefore 6x minus x squared is equal to also y on the other curve. So that is x squared minus 2x. So you have here 2x squared minus you have 8x equals 0. And divide 2 to both sides, simplifying, we have x squared minus 4x equals 0. Then we factor out x, it's a common. So x times the quantity x minus 4 equals 0. So here, we have two roots. X is 0 and x is equal to 4. We have here x is 0. So x minus 4 equals 0. Therefore, x is equal to 4. So 4 is the other intersection. So x sub 2 is equal to 4. X sub 1 is 0. So this is 4. So we need to find what is upper y and what is lower y. So your lower limit is 0. 0 to 4. So what is y upper? Now y upper is the graph that touches the upper part of your strip. So it touches the curve y is equal to 6x minus x squared. So that is the projected downward curve. So that is 6x minus x squared. You have this equation. And the lower y, of course, the other parabola. The equation y is equal to x squared minus 2x. So the projected upward parabola. So y upper, that is 6x minus x squared minus lower y. So that is x squared minus 2x. So this is differential of x. So area is, we have this 6x minus x squared. So 6x minus x squared. So minus x squared, negative times negative, that is positive. So plus 2x. Then we simplify. So the definite integral of, we have here 8x minus 2x squared from 0 to 4. We have here differential of x. So use the calculator to solve this. You can use power formula, but the easiest way is to use your calculator. So equals, we have here 64 over 3. So that will be our final answer. So that is 64 over 3 square units. So see you guys in my next video, and God bless everyone. Thank you for supporting this channel. See you guys.